Hello everyone and welcome back to our class in Artificial Intelligence and Machine Learning in Finance. We've fitted a multi-layer perceptron to our data example of digitized digits, handwritten digits that we wanted to digitize and to predict. And in this video we are going to have a look at a deep model or a deeper model after having seen how to deal with overfitting in our data. So we want to fit a deeper model, and therefore we add two additional hidden layers to our multi-layer perceptron. Actually, before that it was only a single layer perceptron. We now add two additional hidden layers and we reduce the number of neurons by a factor of 2 in each consecutive layer. So it gets more sparse as we move upwards to the outputs. And again, we apply dropout with a dropout rate of 50% to each hidden layer for regularization of our neural network. So we now have a truly multi-layer perceptron. It's model 3. Again, it's fitted sequentially, and as you can see, we have layer dense. We start with 256 neurons, the ReLU activation function. We use dropout, then we use 128, again dropout, 64, and finally we have our output layer with 10 binary response variables, and then we use the activation function softmax. This is the summary. Actually, with the multi-layer perceptron, we now have 243,000 parameters. All of these are trainable, and as you can see, interestingly, in comparison to the single layer perceptron from before, the number of parameters doesn't increase that extremely when adding a second and a third hidden layer. So we move from 204 to 243,000 parameters. We continue as before. We compile and fit the model, again using cross entropy and accuracy, 50 epochs, batch size of 64, and we use 80% for training and 20% of our available data for validation. We visualize the training process, and as we can see now, actually the accuracy is quite high for both the training and the validation set, and actually the loss is also rather low for both the training, not surprisingly, but also for the validation set. And if we compare this to the single layer perceptron, actually I have to delete some of my drawings from the previous video, and you can see now that yes, even though we're using the same regularization, using two additional layers leads to a better performance. We now have a higher accuracy and comparable loss. So to evaluate the model, we use our test data, X-test and Y-test, and here we get an accuracy of 97.7% for the deep model. Now, in the next video, we'll have a look at early stopping as the second way of regularizing a multi-layer perceptron.